Okay, so here we are in the lab again, and the previous video was an introduction to MainBrain, and so this video is going to dive a little bit deeper into MainBrain's hardware and the basic layout of the board and the idea of how MainBrain works. So before we dive down into it, I just want to mention that all the stuff that we learn here, the MainBrain, everything to do with MainBrain is I'm going to make available to all of you out there. Um, if I'm going to get the Gerbers online, I'll get a place on my website and set up and stuff eventually as we move along. But yeah, I'll get the Gerbers on there. I get the schematic on there, bill of materials, uh, everything else. Any kind of documentation of how it works and stuff and firmware will be available to download for free. And you can take the Gerbers and you can submit it to a PCB place like I use PCBWay, and you can just email it to them in a zip file, and if they'll look over it and check it, and if it checks out, I mean, in 3 or 4 days, you have PCB boards. So yeah, it's going to be available for anybody to build MainBrain if they want to. All right. Okay, so let's take a dive down into MainBrain, and let's do a diagram, a block diagram of the different parts of MainBrain, and then we'll break it down into the individual modules, and we'll discuss it in more and more detail as we go along. And then pretty soon, once we get past that, then we'll start building a MainBrain. And I'm pretty sure, I'm thinking that once we get through this, we're going to have to jump over to surface mount devices, because many of you might not be, familiar with the different surface mount devices, because a lot of hobbyists are intimidated by it because they're so small, and they don't have pins that you can put through the board and solder on the back with wires and stuff. So it becomes a whole different ball game with surface mount, but it makes your project so much more compact, and it reduces noise tremendously. And once you get past the initial, SMT scare, then it's really great. And I don't even, if I can get away with it, I don't use any through hole stuff. The only through hole stuff we use on MainBrain is like the power connector and the USB, because you're pushing and pulling on that thing over a long period of time, a long lifetime, hopefully. And you don't want it to break off the board, because just mounted on the surface, you can pull loose the traces and it'll pop right off of there under, excessive force. So, but other than that, everything is surface mount. All the connectors, other than like I said, the USB and power, that's all surface mount. So we're going to have to take a dive into that so that everybody knows what surface mount is, and the terminology and different things like that. All right. So that's coming up. Right now, let's do a block diagram of MainBrain and get an idea of what it's all about. So the very first thing, the main important thing, the main engine, the brain of MainBrain, is the microcontroller. And so we have a microcontroller, and it's a PIC 32MZ microcontroller. Okay, so then I assemble the board the same way. I start with the CPU, I solder the CPU on there, and then you have some bypass caps, about 8 of them that go around it for noise immunity and stuff. So the MX, the PIC32MX was really specific about having the certain caps, but the MZ here, you could probably not put them on. and it would still function. But that's the first thing we do. We're going to put the microcontroller on there, the support caps around it, and then the next thing you need is a power supply. And MainBrain works on 3.3 volts. The core runs on 1.2, but you have to supply 3.3 volts to it. And the most important part, other than the microcontroller, is the power supply. So MainBrain has its own switch mode power supply. And we'll get into why that is later, because if you use a linear supply, there's some problems that arise. And so I ended up having to do a switch mode power supply. So we'll get into that later too. So we have a switch mode power supply, and it puts out 3.3 volts. All the chips on the board run on 3.3 volts DC. And the power supply itself, it can run on 24 volts DC down to about 5 volt DC. So like I said before, I don't actually know how low it can go yet because I haven't tested that. So we're going to test that together and see how low MainBrain can go before it drops out and can't boot up. So, okay, so we got the power supply, 3.3 volts. It can put out up to 3 amps, 3 amps maximum. That's what it's rated at. I don't know if we'll have to test that too. I haven't tested it above 1 amp, maybe 1.5 amps. So we'll have to test that too. We'll test out how much load we can put on it before the power supply drops out. Now, this power supply has thermal protection and overload protection. So if it becomes overloaded or shorted, it shuts down and it goes into what they call hiccup mode, and it tries to power back up. And as soon as the current becomes too great, it shuts back off. So it kind of goes up and down hiccups until either you remove the power to it or the short goes away. So it's a very robust power supply, and it's simple. It's not that expensive, and it's way more efficient than a linear regulator. So from between the 24 volts the input voltage, whatever it may be, between the input voltage and the actual power supply, we have a diode. And that diode protects it from reverse polarity. So if you accidentally reverse the plus and minus of your power supply, it won't fry all the chips on the board, because without protection, it will damage the board. So we put a diode here to make sure that it's somewhat protected. All right. So then the next thing is you have to get your program into the microcontroller. So in order to do that, you use a debugger programmer from Microchip. And so they're about $50 part, and you plug it through the USB, you plug it into your PC, and you download an IDE, an integrative development environment that they provide, and it's free. That's one thing good about Microchip. You get a lot of stuff from them, and that's one of the reasons that I use them on MainBrain. And so you need a special port to program the firmware. They call it the firmware. That's your program that goes into the microcontroller. So in order to program the firmware into your device, you have to have this port. It's a 5-pin header that's called the ICSP. So that's the next important thing for MainBrain. So you have, let's go over here. So you have the ICSP port, ICSP, and that programs data into the microcontroller. Now, ICSP stands for in-circuit serial programming. So basically, we'll get into this. There's 5 pins. One's ground and one's 3.3 volts. So you download from your PC, you download your firmware through the in-circuit debugger, they call it. It's called the microchip PIC kit. They have the 3, 4, 5. They have one called a Snap, which is like, I think you can get that for like 35 bucks. But yeah. All right, so your program is loaded into the microcontroller through this ICSP port. And we'll get into that too. We're going to go through all the steps of everything. So don't be overwhelmed by it. This is just a basic flow diagram and how it works. Okay. And then we'll get into each different module later. Okay, so the next thing is the dual port SRAM. That is one of the key parts of MainBrain, and that's how it gets data to the and data in and out from the outside world. So that would be a dual port RAM. We have a dual port RAM here. And so it is basically split into two. So you have, it has 8K by 8 bits. So it's an 8-bit data bus, and everything around on MainBrain is 8-bit except for the display, and the color information is 16-bit and can be 18-bit. All right, so the microcontroller communicates directly back and forth to this dual port SRAM. So then, like I said in the previous video, the reason this is so important is because the PIC just takes care of the local housekeeping. It doesn't have to worry about anything outside directly. It just writes commands inside this memory, which basically it has 8,000 8-bit registers, basically is how it works. So you write to these registers, and based on your firmware, it can get data back, and it sends commands. And it's just all the PIC reads and writes to this memory, and that's how it communicates. So then the peripherals read these memory locations, and they get their commands, and then they send back status information. They write it in this, and then MainBrain reads it, continually updates, and then that's how you get data back and forth. And I'm expecting 1 megabyte per second. That may be a maximum, and we'll test that. We have to test that, and we'll test that together. So that's the main I/O of MainBrain. The firmware, the code that you write to make it do what you want it to do, comes in through the ICSP port, gets programmed into the internal flash memory of MainBrain, and then MainBrain runs the program, runs the firmware, and reads and writes to this 8K by 8 SRAM. It's an SRAM, static read-only memory. And then the peripherals can read from that SRAM and get their commands and send back status information. So that's the flow of data. But then also MainBrain has 4 megabytes of flash memory. And that can store user information. It can be a program to load later after MainBrain starts up, or it can just store information. It's whatever the user desires. So whatever you write your firmware to do, it can store whatever kind of information you want in here. And it is 4 megabit. There's a distinction because the SRAM is 8K by 8 bits. So that's like 8,000 bytes. This is 4 megabits. So you divide that by 8 and you get how many actual bytes of information is stored in there. They kind of do it that way. Okay, so then the next important part is the display. Now, MainBrain can run with the display or without. If you run it without the display, you have to use the Windows program and control MainBrain through the USB and with your PC, which you can do. We got that going too. But if you use MainBrain's display, then it's a touch screen, so you can write your firmware to interact with the touch screen. And it's a capacitive touch, and it works real well. I'm impressed with that. The capacitive touch display works real well. So we have the display, and it is a 480 by 320 pixel display. And MainBrain normally runs with 16-bit, which is an RGB, let's see, RGB 565, I believe. We'll get into that format. There's different RGB formats based on how many pixels or how many bits you program it with. And so the display could go 18 bits. And MainBrain can supply 18 bits, but normally I use 16 bits mostly because that still provides a very good color. Okay. Okay, so then the next thing is the reset supervisor. The reset supervisor is just a small component that holds the reset pin low on the microprocessor so that it can't start booting up until the voltage level, the 3.3 volts on the board, stabilizes. So when you plug in your voltage of 24 volts, the power supply has to power up. It has to start switching. It has to get the 3.3 volts out and stabilized. So this reset supervisor holds the microcontroller from booting up until that voltage stabilizes. So we have a reset supervisor, and it goes into the microcontroller, and it also sends a reset signal out to the peripheral boards. They can use it or they can do their own thing, but this makes sure that everybody is on the same page when the program starts. The next thing is we have a buzzer. I had a little extra room on the board, and so I'm like, what can I do? And I'm like, I'll put a speaker on there. It's a little buzzer. It's not really a speaker, it's a buzzer. Maybe we could put a speaker on it later so you can play a little better sounds than just beeping. But right now, we just have a buzzer. So we just have a little buzzer right here. And the microcontroller controls that. And then in my firmware, when it first boots up and everything's good, then it just beeps, beep, and then you know that it reached that point at least. It's kind of like a power on self-test in a very crude way. Okay, so then we have an output port on the end, and it has 72 pins, but half of them, since it's for a ribbon cable, then half the pins are ground. So every other pin on there is a ground. So you have 34 pins of I/O, which basically consists of an 8-bit data bus so the peripherals can communicate with the SRAM, and then you have all the address lines to address all 8K, and then you have VCC come out here, actually VDD we call it. So the 3.3 volts go out, so you can power a board with that, even though some boards may require an external power supply, but at least you get 3.3 volts available to the peripherals. Okay, and then next we have the USB connector, which is a mini A USB, and it's right here. So USB, and that is a high-speed USB. So that is 480 megabits per second. And that's a Mini A. And the reason I used a Mini A is because it's a little more robust than like the other thinner ones for like the Samsung phones and stuff. Yeah, because those can bend and pull apart. But the Mini A it's pretty robust. So you're going to get a long lifespan on plugging and unplugging of the USB on the MainBrain. So, all right, that's the USB. When we program the firmware into the microcontroller, the reset pin is used to do that. That's one of the pins that the debugger programmer uses. So we have a small header with a shunt on it that can be removed, and that goes right here to isolate the reset pin from the ICSP when you program it. You don't always have to do it, but it can cause reset issues when you have the debugger connected and you power up MainBrain. Sometimes it likes to stay in reset, or yeah, basically just stay in the reset. So, and I put this jumper in so that you can like disconnect the reset from the ICSP when you program it, if you need to. You don't always need to, but it's the option is there. Internal to the microcontroller is a 12-bit analog to digital converter. And so I use that on board to measure the power supply input voltage. So it takes this voltage right here, and it's on the other side of the diode, because even though you get a 0.6 volt drop across the diode, you want it still to be on the protected side, because if you didn't, you could still run voltage into the microcontroller. So on the protective side of the diode, we measure through a voltage divider. We measure the input voltage. All right. So then, since we got a fairly high current, and we're going to have peripheral boards attached to the power supply of MainBrain, then we want to monitor the current. So we have a voltage, a current monitoring device that sends the current. It converts the current into a voltage and then sends that to the DAC as well. So that's the IN. Actually, I probably should call that the I, the board current. So this circuit consists of a resistor, a 100 milliohm resistor, and a device that measures the voltage drop across this resistor and converts that voltage into a value that the ADC can read and compute the consumption, the current consumption of the board. And that would be the total, that would be with the peripherals as well. So any load on this power supply is monitored by the current sensing circuit. All right. Okay, and one thing that I forgot to mention is, for the display, we control the brightness of the display with the PWM signal from the microcontroller. So we have a little PWM signal coming out of the microcontroller, and it goes through a MOSFET. Goes through a MOSFET, and that's controls the brightness of the display. So the faster you run the PWM, the brighter the display. And in my firmware, I have 10 different levels, but you can program it however you want. And that the display takes about 150 milliamps. So if you want to save on power consumption, you can dim your display, or you can do a screensaver, or where the display turns off, or however you want to do it. So one thing that got like chopped out of the editing process was the GPIO. If you were paying attention, all of a sudden this GPIO thing popped up, and I never said anything about it, but it got chopped out. So in addition to the data bus and the address bus, we have several GPIO signals that you can program. Some are serial, and you can do the SPI serial interface, or you can use digital IO, whatever you feel like using. We're going to get into this a little closer because some of them are going to get used for the addressing of the peripherals. So I'm still in the process of that, and we'll work that out together too. And that is basically MainBrain. So now that we have a basic understanding of how MainBrain works, then we can break down each individual section and take a deeper look at it to understand how it works better, so that you can build your own microcontroller.